Okay, now class, we're going to talk on tissue repair. Now we'll do this again in the skin section, which integumentary, chapter 5, but we'll do a little bit here. All right. In tissue repair, the initial step in tissue repair depends on the extent of injury. If the injury cuts a blood vessel, then the first step is bleeding. If no blood vessel cut, then it's inflammation. So here would be, if injury includes a blood vessel, bleeding, inflammation, migration, proliferation, and maturation. Let's look at it. Okay, bleeding can be good if it's not too much. Bleeding accomplishes 3 tasks. It cleanses the wound. When the blood clots, it forms a stringy substance called fibrin that can be used as a scaffold to allow cells to come in and repair. And so also the fibrin, let's say you cut your skin, fibrin comes in, gets there. There's a lot of water in it. When the air hits it for a while, it dries the water off the top, and that forms the scab. The scab covers the wound. Okay? Here would be a cut head. You're doing some bleeding. Here's the scab. So you cut down. Now, the cut has to be past the epithelium. Epithelium is avascular. So this cut has to go deep. If it's just epithelial surface, then that's what we call a superficial wound. If it goes below the epithelium, we call it a deep. A deep is the only one you can get some bleeding from. Okay. The next thing that's going to happen is inflammation. Cells in this area, mast cells and other cells, will start to secrete histamine and heparin. These mast cells will cause inflammation, which will kind of cleanse the wound. White blood cells will come in. Okay, here's white blood cells coming in there. Histamine is a vasodilator. That's why in inflammation you'll see it to get red. It opens blood vessels up. So the inflammation cleanses it, a perimeter around the wound, releases inflammatory chemicals, dilation of vessels, main one histamine. There's an increase in vascular permeability, so white blood cells can come out easier. Get there to fight things. Okay, let's go a little further. The inflammation sets the stage right there. Local blood vessels become more permeable. We see migrating white blood cells. The migration, one are white blood cells, but the other are the parenchymal cells for healing. Now let's go up here. Parenchyma, most important. If it is the epidermis, though we haven't done skin yet, it would be some cells from the stratum basale, some keratinocytes. We'll talk about that. It won't make much sense. But we can say if it's in the connective tissue, fibroblast, remember those are the cells, so they would come in and use the fibrin strands, that fibrin, remember the clot stuff, to come in and try to heal this area. So that's the migration. That's the migration. Also, macrophages come in and try to clean everything up. Okay? That's the migration. Proliferation. Now, the epidermal cells need to proliferate to fill back up. The dermal cells need to also do that too, proliferate. Fibroblast. Now, we need to get blood vessels to grow back in this area. Because if blood vessels don't grow back, it can never heal. You got to have blood vessels coming back. The technical term for growing of new blood vessels is called, this is a term I want you to know, called angiogenesis. That's the process of forming new blood vessels. Another term is called neovascularization, new vessels. So we need that wound to do neovascularization, angiogenesis. Now, in medicine, when you see the wound to start for blood vessels to come back in, see, diabetics have a hard time getting blood vessels. They have small vessel disease. So that's why their wounds sometimes don't heal that well. But however, what you're looking for is this angiogenesis, neovascularization. And when the wound starts to get these blood vessels back in, we call it granulation tissue. Granulation tissue is when the new blood vessels start coming back in. So you want to see good granulation tissue in the wound, because that shows that the wound is starting to revascularize. Blood vessels are coming back. Okay. So migration, proliferation, the clot is replaced by granulation tissue, which restores the vascular supply. Fibroblast, those cells, that's the soft connective tissue, produce collagen to bridge that gap, to get things healing. Surface epithelial cells migrate to try to take care of the surface. See, here's that, still you got that clot up there, that scab. But once things grow back, the scab has nothing to hook to and it falls off. Let's go further. Maturation. Completion of proliferation and loss of scab. See, what happens is that scab is holding down into here. But once the epithelial cells grow back, the scab has nothing to hold to. So it'll start break. I know you've all been cut, and you'll start to see it break off in pieces. If you pull it too early, you'll see bleeding under there. Okay? So here's that regenerated epithelium. Now, this area here, fibrosis, is scar. The area still formed a little scar. Fibrosis is scar. It didn't completely heal and bring back the soft connective tissue. What is scar? It's where collagen connective tissue forms where something else shouldn't. It's where collagen connective tissue. So this is a little scar tissue here. So when you look at your skin, let's say you got cut, and you can see that scar. That scar is where connective tissue is where the epithelial tissue should be. That's what a scar is. The technical term is fibrosis. Osis, the process of putting fibers. Fibrosis. Okay? So we'll talk about that. So that gives you an idea. And again, we'll do this again when we do the skin. In the skin one, we'll even talk about cuts and burns. But this sets the basis. I want you to study this. This sets the basis. All right. Thank you there.